Okay, today we're going to do something called implicit differentiation, which is a really handy trick for finding derivatives of functions that are difficult to solve for y, and we can even use it to find derivatives of things that aren't even functions. Okay, let's look at this. Sine of y plus y cubed equals 6 minus x cubed. And suppose we want to find the derivative. Now, that question by itself, I say find the derivative, 99% of the time, that question is not going to cause any confusion. But in this case, I should be a little bit more specific and not just say find the derivative. What I should say is find the derivative of y with respect to x. Because, here, look for a second. What if I just wrote y equals 6 minus x cubed? And I said find the derivative. I don't think that would cause any confusion in that case. You know, you have here y equals this stuff, 6 minus x cubed. It's pretty clear that y is a function of x. And so if I said find the derivative, I think it's pretty obvious that we mean find the derivative of y with respect to x. But up here, we have a much more complicated situation where it doesn't just say y equals this stuff done to x. What we have up there is stuff being done to x and also stuff being done to y. And in a case like that, I would not want to just say find the derivative. I should say find the derivative of y. And if I want to be even more careful, I would say find the derivative of y with respect to x. Okay, you might say, well, aren't we always finding the derivative of y? So why does that make any difference? And the answer is, we usually are finding the derivative of y, but there's no rule that says that. If somebody wanted to find the derivative of x, they certainly could. Like, if I write this again here, y equals 6 minus x cubed. The derivative of y, which would be y prime of x, what would that be? It would be negative 3x cubed, squared, correct? But there's no rule stopping us from finding x prime if we wanted. We could take that equation and we could solve it for x, and we would get x equals the cube root of 6 minus y. Do you agree with that? I'm not showing the algebra because everybody should know how to do algebra. But take a second and make sure you agree with that. Which is, maybe I should write this way. 6 minus y to the power 1/3. So there's nothing stopping us if we wanted to find the derivative of x with respect to y. And in that case it would be, now this is going to give you some practice on the chain rule. What should I do? I should take that down. So I get 1/3 6 minus y, and then what should I do next? I should subtract 1 from that, so the exponent would now be negative 2/3. And then the chain rule says to multiply times the derivative of the inside. If y is my variable, then the derivative of 6 minus y is negative 1. Whoops, that should be blue. Okay, so we would end up with negative 1/3 times 6 minus y to the negative 2/3. Okay, I'm just trying to make the point that 99% of the time we treat x as the independent variable and y as the dependent variable. And so when we're finding derivatives, we're finding the derivative of y with respect to x, because y is a function of x. But we can, if we wanted to, solve for x, and then we have x as a function of y. And then you could find the derivative of x with respect to y. So in a situation where it's not obvious which one you want to do, if I want you to find the derivative, I should tell you the derivative of which variable with respect to which variable. Okay? And in Leibniz notation, remember that y prime of x would be written dy dx, and x prime of y would be written dx dy. Okay? All right, now, that was a little bit of a tangent. Let's get back up to what we were looking at. That's written in black. So suppose I asked you to find the derivative of y with respect to x. Based upon what we've learned so far, you would first have to solve for y, and then 2, find the derivative. Doesn't sound particularly difficult, right? But this part here might be difficult, or it might not. In this particular case, it'd be a little bit difficult to solve for y. Okay? I mean, you could go ahead if you want and try it. You could pause the video and take sine of y plus y cubed equals 6 minus x cubed. And you could, whoops, I didn't mean to do that. I pressed the wrong button there. You could do some algebra and solve it so that it says y equals some stuff there. The thing is, I think you're going to get stuck. I don't think you're going to be successful. Okay? So we have a problem with this, which is algebra, not calculus. You see, so we have algebra standing in our way, not letting us do the calculus. That's the problem. Okay? And it might even be true that y is not a function of x. If you graph that thing, it might fail the vertical line test, in which case you would not be able to solve it for y in terms of x. Not get a function, at least. So how do we get around that algebra standing in our way, not letting us do the calculus? Well, we use this thing called implicit differentiation, which is actually not a different kind of differentiation at all. It just has its own name. Okay? Meaning that we're not going to solve for y first. We are going to do the calculus on the equation exactly as the equation stands right now. The only thing you have to know is how to do derivatives, and you need to remember the chain rule. That's going to come into effect, the chain rule, many times here. Okay? We are treating y as a function of x. Let's put that down here. That's important. Okay? So to find the derivative of y with respect to x, we treat y as a function of x, even though we are not going to solve for y in terms of x. Now, what that means is this. Let's look at the first part, sine of y. What's the derivative of sine? It's cosine, right? Let's do this example really quick. What if I said sine of x squared. And I said, find the derivative of that with respect to x. What would you get? You would get cosine of what? X squared. And then the chain rule says to do what? Times 2x. Right? So we would have 2x cosine of x squared. Now, why this? I said it's because of the chain rule, but my question is, what's the 2x coming from? It's the derivative of the x squared, right? Okay, so same idea. If you have sine of y, and y is treated as a function of x, then when you want to do the derivative, you would get cosine of y times the derivative of y, which I'll just go ahead and write y prime. Okay? And why is this here? Because of the chain rule. And where is it coming from? It's the derivative of this function. Remember, we're treating y as a function of x. So after doing the derivative of sine, which gives me cosine, then I have to multiply times the function that is on the inside. I multiply by the derivative of the function on the inside. That's what the chain rule says to do. Okay? Now, just for fun, let's go ahead and write sine of x, and let's write down the derivative. And I'll tell you that it's not that the rules are changing. These are actually the same rules we always had. What's the derivative with respect to x of sine of x? It's cosine of x, right? And that's the answer. Now, what if someone came along and said, how come we don't have to multiply that times x prime? What would I say to that person? I would say, well, technically you are, but I would ask them, what is x prime? What's the derivative of x with respect to x? In other words, if I wrote y equals x, then what is y prime? It's 1, right? So in this case, you'd have cosine of x times 1, which is what? Which is cosine of x. So you see, it's not that the rules have changed. It's the same rules as before. Okay, does that make sense? Maybe, maybe not, right? Let's try it out. Let's find the derivative of y from that equation up there at the top. Okay, so we have cosine of y times y prime. We worked that one out down below. Okay, and now plus, now what's the next one? So I have y cubed. So what would I do first? I would take that down, and I'd write 3y. Then I would subtract 1, and my exponent would be 2. And then because of the chain rule, I would multiply that times the derivative of y. And then I hit the equal sign. Then I get to the other side. What's the derivative of 6 with respect to x is 0. Then I have minus x cubed. The derivative of that with respect to x is, when I say, by the way, with respect to x, I'm just saying x is the independent variable. That's all I'm saying. Okay? X is the input variable. So what's the derivative of negative x cubed? It is negative 3x squared. And then again, do I need to multiply times x prime? No, I don't, but I can if I want, because x prime would just be 1, and I would get negative 3x squared times 1, which is negative 3x squared. Okay? So that is called implicit differentiation, and the calculus is now completely finished. Okay, the only thing is the question would have said find the derivative of y. So in other words, find y prime. And you might say, well, there it is, I found it. It's here and it's also here, right? But of course, when I say find y prime, what I mean is tell me what y prime equals. So even though we're done with the calculus, we have a tiny bit of algebra to do to solve for y prime. Okay, but it's easy, and it's just algebra. What I notice is on the left, there's two terms, and they each have a y prime, so let's factor that out. And then we will divide both sides by the stuff in parentheses, and we get our answer. Y prime equals negative 3x squared over cosine of y plus 3y squared. And there we go. That's y prime. Okay? Now if I asked you, find the slope of the tangent line at a certain point, what would you do? Well, in that case, you would just take the coordinates of the point and plug them into here. You would need the x and y coordinate both. And you would plug them into there, and that would tell you the slope of the tangent line at that point. Okay? That's all there is to it. Let's just keep practicing, and we'll do some more examples here. Okay, so here's one that says y cubed plus x squared y to the fourth equals 1 plus 2x. And it says find y prime. Okay? So let's do that. On the left-hand side, we have y cubed, just like in the earlier problem. So what would be the derivative of y cubed? It would be 3y squared times the derivative of y. So 3y squared y prime. Okay? And then plus, and now we have another term. Now, let's be careful here. I have two functions of x multiplied together. We have x squared, and we have y to the fourth. Remember, we're treating y as a function of x. So x squared is a function of x, and y to the fourth is a function of x. And I have those two functions multiplied together in a product. So to do the derivative, I need to use the what? The product rule. So we will do the derivative of the first, which would be 2x, times the second, which is y to the fourth, plus the first, x squared, times the derivative of the second, and what would that be? 4y cubed times y prime. Okay? So you might be picking up on the fact of every time there's a y and we do the derivative, you just have to remember to multiply times y prime at the end. But I want you to understand why. It's because of the chain rule and because y is a function of x. Okay, then what do we hit? We hit an equal sign. Okay, that's not a problem. And then on the other side there's a 1. The derivative of 1 is 0. There's a 2x. The derivative of that is 2. And there we go. That's done with the calculus. Now we just need to do some algebra to solve for y prime. So how about if we move this to the other side? We'll get 3y squared y prime plus, and then that last part I'm going to just move the 4 in front. So 4x squared y cubed y prime would now be equaling 2 minus 2xy to the 4th. Factor out the y primes. And divide both sides by the quantity in parentheses. And then we'll be done. Oops, that should be not y squared, it should be y cubed. And there's our answer. That's what y prime equals. Now, just for fun and practice, let's answer this question. Find the equation of the tangent line at the point 0, 1. Okay? I'll write it down. What if that was our original question? Find the equation of the line tangent to the graph of that equation at the point 0, 1. Okay? What if that was our original equation? So what would we do? First we would find y prime, which we did. And then we would plug in the coordinates 0 for x and 1 for y. Okay, and I would say at 0, 1, y prime equals, I could have put an equal sign, I just decided to write out the word. Okay, what would it equal? It would equal 2 minus 2 times 0 times 1 to the 4th over 3 times 1 squared plus 4 times 0 times 1 cubed. Work that out. We get 2 on top, 3 on the bottom. So it's 2/3. That's the slope of the tangent line. So what do we have? Our tangent line would be y minus 1 equals 2/3 times x minus 0. There we go. We're done. But if you prefer, you could manipulate things around and rewrite it in this order. Y equals 2/3 x plus 1. And there's your tangent line. All right. Not too difficult, really. Just a matter of getting the hang of it. Let's do another practice. Okay. So in this example, we have the equation sine of x squared y squared plus y cubed equals x plus y, and it says find y prime. Okay, so that's the same question we've been answering before. All right, so let's run through it. I've got sine of something. What's the derivative of that? It's cosine of that same thing. times the derivative of the stuff inside. All right, now the stuff inside is a product of two functions of x squared and y squared. So I will have to use the product rule. So I get the derivative of the first times the second plus the first times the derivative of the second. That means the derivative of 2y. I'm sorry, that's not right. I meant to say the derivative of y squared, which will be, let me move that over so I have room. 2y times y prime. Okay? All right, now, then we have plus y cubed. We've seen that in every example so far. I should write 3y squared times y prime. And on the other side, we have x. The derivative of that is 1. Plus y. The derivative of that is y prime. How come the derivative of x is 1, but the derivative of y is y prime? Because we are treating y as a function of x. So we're finding the derivative with respect to x. That's why the derivative of x is 1. Okay? And the derivative of y is not 1 because y is a function of x, and we're doing the derivative with respect to x, not with respect to y. Okay, let's just clean this up here because we still want to solve for y prime. So let's do this. Let's write 2xy squared cosine of x squared y squared. That takes care of this. Okay, and then got that, which will be, let's put the 2 in front. So let's do this. Let's write 2x squared y times cosine of x squared y squared times y prime. I like to put the y primes always at the end. Okay, and then we have plus 3y squared y prime. Then we have equals, and then we have 1 plus y prime. So this term has no y prime. We'll send that to the other side. Here is a y prime. We'll send that to the left. So we will end up then with 2x squared y cosine of x squared y squared times y prime plus 3y squared times y prime minus y prime, which we brought over from the right hand side, and then that's going to equal 1 minus 2xy squared cosine of x squared y squared, and that is what we brought over from the left. And now on the left, there's 3 terms. They all have a y prime, so I'll factor that out. And then we divide by the stuff in parentheses on the left, and that'll give us our answer. Y prime equals this over this. There's our answer. Okay, does that sound doable to you? Let's do one more question. I'm going to import a picture from the book. Okay, there we have the unit circle. with the tangent line at the point 1/2 comma root 3 over 2. And what we want to do here is find the equation of that tangent line. Okay, so let's start by writing down the equation of the circle. That's the unit circle. So you know the equation of that, right? It's x squared plus y squared equals 1. Okay, so let's find y prime. This one's actually easier than the ones we've done so far. Let's find y prime. We get 2x plus 2y y prime equals 0. So 2y y prime equals negative 2x. So y prime is negative 2x divided by 2y, which is just negative x over y. So at the point 1/2 comma root 3 over 2, what would we have? We would have negative 1/2 over root 3 over 2, which is, of course, negative 1 over root 3. Okay, which I am perfectly fine with writing that. I know you may have been told in the past to rewrite that as negative root 3 over 3. You can if you want. I don't see a need for that myself. Okay, so our equation of that line is y minus root 3 over 2 equals negative 1 over root 3 times x minus 1/2. And if you want to put that into slope-intercept form, then you would have, let's see, y minus root 3 over 2 equals negative 1 over root 3x plus 1 over 2 root 3. And then we would take the negative root 3 over 2 and move that to the other side. And it would have a plus root 3 over 2. Here's your slope, and here's your y-intercept. Okay? All right, I think that's probably enough practice, but if it's not, if you have questions about it still, just come to the discussions and I'll be happy to help you some more.